This is Algebra 1, spring test for week number 6 study guide. First set asks us 3 questions, actually the latest thing of what we did. Tell if something has no solution, one solution, or infinitely many solutions. Tell about these systems. We know that systems, if they are parallel lines, there'll never be that point where they cross each other when they're parallel. So there'll never be that one point that the two equations have in common that makes the system correct. Therefore, if we identify two lines from the system as being parallel, there's no solution. However, if it's the same exact line, meaning it has the same slope and also the same y-intercept, then it's the same line that has an infinite amount of points that it shares in common with the other line. Therefore, it'd be infinitely many. If it's not parallel, if they have different slopes, no matter what, if the slopes are different, then there's going to be one solution. It'll be that one point where they cross. That being said, if we look at number 1, it says y equals negative x minus 4 and y equals negative x plus 4. What you want to do is you want to ask yourself, what is the slope of these two equations? Remember, y equals mx plus b. Your m value represents the slope. In this case, both of these slopes have a negative 1 value because there's a negative 1 that's multiplying by x. Remember, m is only the coefficient that's multiplying by x, not negative x in this case. So both of these values of slopes are negative 1 for both of them. Therefore, that's pointing us to the fact that they may be parallel lines. The other part you have to check is you have to check the b value or the y-intercept values. If it's the same value, then it would be the exact same equation, which means they would share every point in common. This is not the same value. They're different. Therefore, when you're looking at this equation, it'll look something like this. Like if the first one goes through at negative 4 and the other one goes through at positive 4 and their slopes go downhill like this, both of those equations will look similar to that. Therefore, they're parallel lines and there'll be no solution. So the answer to number 1 is no solution. Number 2 says y equals 5x plus 2. So if you look at the first equation, y equals mx plus b. So the slope of your first equation is 5. So let's just take a look at that for just a second. The next equation, y minus 2 equals 5x, doesn't tell you what the slope is right away. You have to move it to make it say y equals mx plus b. In order for you to move it to y equals mx plus b, you move whatever on the left-hand side that's not y. In this case, it's negative 2. You want to move it over to the other side. If it's negative 2 when it's on the left of the equal sign, when you move it over, it becomes positive 2. So y doesn't move. Y stays just like it is. Equals doesn't move. 5x doesn't move. It stays just like it is. And then again, negative 2, when it moves, it becomes positive 2. So the slope of that equation is also, its m value 5. So they have the same slope. So that's pointing towards parallel lines again. However, in this case, unlike number 1, the y-intercept values positive 2 are exactly the same. So you have both the same slope and the same y-intercept. So when you look at these equations, they'll look something like this. The first equation will go through at 2, and it'll go up 5 and over 1. It'll look way straighter than that. It'll look something like that. The second equation, when you do it, it'll look something like that. It'll be the exact same equation, which means it shares an infinite amount of points. So infinitely many solutions. And then the third equation is easy to see again. You can see both of the slope values. The slope value of the first equation, y equals mx plus b, is 1. The slope of the second equation, y equals mx plus b, is negative 3. These slopes are different. Remember, it doesn't matter where your y-intercept is. If the slopes are different, then somewheres on your graph they are going to cross in one spot. Therefore, this will be the case where there is one solution. They'll cross in one spot. The graphs will look something like this. The first one will go through at 2, and it'll go up 1 and over 1, so it'll look something like that. The other one will go through at positive 3, so it'll be here, and it'll go down 3 and over 1. The equation will look something like that. But again, to answer the question that's asked, they're going to cross at 1 point, so there'll be one solution. Just as a recap to that section, if they're parallel lines, that means they have the same slope and different y-intercepts like number 1, there'll be no solution. If they're the same slope, the same line exactly like number 2, because they both have the same slope and y-intercept, they're going to cross at every point, or they'll share every point. So it's an infinitely many amount of solutions. And then for number 3, they have different slopes. Again, it doesn't matter what the y-intercept is. If the slopes are different, they're going to cross in one spot, so they have one solution. Number 4 says solve the system using substitution. I find the easiest way to do substitution is to write them alongside each other. Y equals 2x plus 2 and y equals 3x plus 9. The reason they're stacked on top of each other is because when you start doing elimination, it's easier for them to be stacked, so where you can see the columns. But for substitution, it just seems a little bit easier to look at it this way. Take a look at your first equation. It says 2x plus 12. That's what it tells you the value of y is. So what that means is in place of y, you can plug it in or substitute it in. That's why it's called substitution. So instead of putting y, we're going to put its new value of y, which is 2x plus 2, or the expression that represents it. 2x plus 2 equals 3x plus 9. From there, just put all of your terms where they belong, or move all of your x's over to one side. You have 2x on the left. You got 3x on the right. Put the smaller one over to the larger one. 2x is smaller than 3x. It's positive 2x, so undo the fact that it's positive by subtracting it. If you do it to the left, subtract 2x on the right. 3x minus 2x is 1x. If we bring the rest down, this part cancels. 2 is left all by itself on the left. Equals stays just like it is, and plus 9 stays like it is. Undo the fact that it says plus 9 by subtracting it. If you subtract 9 on the right, subtract it on the left. 2 minus 9 is negative 7. You still have equals, you still have x, and the 9's cancel itself out. So x's value is negative 7. So that gives us, we want something that says x comma y. X comma y. So we just got our value for x, it's negative 7. But we want to find out what y's value is. In order to find out what y's value is, take that value for x, negative 7, and bring it back up into the first equation. Y equals 2 times x plus 2, or y equals 2 times our new value for x plus 2, which is negative 7. When you simplify that, 2 times negative 7 is negative 14. Bring down plus 2. And when you combine negative 14 plus 2, y equals negative 12. Now you have your value for y. You had your value for x a second ago, negative 12. Again, don't do all that work to get x's value perfectly correct and y's value perfectly correct, and reverse the order here. Make sure you put x comma y, negative 7, negative 12. Number 5, we're still using substitution. We'll go a little bit faster through this one since it works exactly like number 4. Y equals 4x minus 9. Y equals 3x minus 5. There's your value for y, so 4x minus 9 equals 3x minus 5. Put all your x's on the same side. 3 is smaller than 4, so subtract 3x on both sides. It leaves you with 1x over here. Minus 9 equals, you still have negative 5 right here. Get rid of negative 9 by adding it to both sides, and you still have x here. Positive 9 combined with negative 5 is going to be positive 4. So x equals positive 4. Take that value for x, plug it back in right there. Y equals 4 times, we just found out our value for x is 4, minus 9. 4 times 4 is 16, minus 9, and y equals 7. So you have x and you have y, x comma y, 4 comma 7. So both number 4 and number 5 are showing systems that are going to cross in one point. So if you compare them to 1, 2, and 3, both 4 and 5 will act just like number 3. There'll be that one solution where the two lines cross each other. Let's look at number 6. Instead of plugging 3x plus 4 in place of y for the second equation, notice how short or how much shorter y is equal to in the second one. It says y equals 2x. So take that one and in place of this y, plug in 2x equals 3x plus 4. Normally you would move your smaller x2 over to your larger x3. In this case, however, you have plus 4 on the right side. So let's move this one the other way. It's positive 3x, so you undo that by subtracting 3x. If you do it here, it leaves you with negative 1x equals positive 4. Undo that by dividing by negative 1 on both sides. X equals negative 4. There's your first value. In order to get y's value, take that and plug it back into the other equation, 2x. So y equals 2 times our new value for x is negative 4. 2 times negative 4y equals negative 8. X comma y, negative 4 comma negative 8. Number 7, x and y intercepts of the line. In order to find the x-intercept, you plug in 0 for y. Anytime you plug in 0 for something, it eliminates it. So you're left with a problem that says negative 3x equals 75. When you divide by negative 3 on both sides, x equals negative 25. That's your x-intercept. In order to find your y-intercept, you plug in 0 in place of x. When you do that, it eliminates that part of the equation, and you're left with negative 5y equals 75. When you divide by negative 5 on both sides, 5 goes into 7 once. There's 2 left over, so it goes into 25 5 times. Positive divided by negative. Your y-intercept is negative 15. Number 8 says solve the equation. We know how to work normally through our order of operations. We work parentheses, exponents, multiplication, and division, followed by addition and subtraction. But when you're trying to undo a problem in order to solve it, you have to work backwards. So you have to work for addition and subtraction first. As you're looking at x, that's what you're trying to get by itself at the end. You want it isolated, saying x equals. It doesn't have that right now. It says 2/3 times x. And then it says minus 4. So the minus 4, we're looking for addition and subtraction. You got to take care of minus 4 first by adding 4. You do that to the left, do likewise to the right. 6 and 4 gives you 10 when you combine them. You still have 2/3 times x. Now that says 2/3 times x. There's no more addition and subtraction, so we finished with the first step. Now we're looking for multiplication and division. 2/3 times x. In order to undo times something, you normally would divide by something, which is what we're going to do. But instead of writing it as divide by 2/3 and then writing the right-hand side as divide by 2/3 and then changing that to multiply by 3/2, because in order to divide by a fraction, you multiply its reciprocal. You can speed it up and just multiply by the reciprocal at the beginning. 2/3 times 3/2 will cancel it out. If you do this, if you multiply by 3/2 on the left, multiply by 3/2 on the right, everything's over 1. 10 times 3 is 30, and 1 times 2 is 2. When you simplify 30 divided by 2, you get 15. This part canceled out, so x equals 15. Number 9 says find the slope. Your slope formula is the change of y over the change of x. When you label them, x comes first, and we'll call this 0.1, and we'll call this one 0.2. So the first number you're looking for is y sub 2. That's this one, negative 2. Minus, you want y sub 1 next. That's this one, 4. Over, x sub 2 is next. That's this one, 8. Minus x sub 1 is last, 3. Negative 2 minus 4 is negative 6. 8 minus 3 is 5. There's no number that goes into both 6 and 5. Your slope is negative 6/5. Number 10 says write an equation with the given slope and y-intercept. Notice it doesn't tell you what form of an equation to use, but you're given a slope and a y-intercept. So use slope-intercept form. So use y equals mx plus b. Your m value is negative 4/3. So in place of m, plug in negative 4/3. Your y-intercept value is negative 1. So in place of your y-intercept value, plug in negative 1. Everything else stays the same. Y equals mx plus b. Write in slope-intercept form of the equation. Again, slope-intercept form, y equals mx plus b. Plus b is first. Where does it cross through the y-axis? At 1/2. So your b value is 1/2. Your m value is how many times it goes up or down over how many times it goes left or right. Your rise over your run. So from the points given right here, you got to go up 1, 2, 3, 4, 5, 6, 7 to get to this one right here. Up 7 is positive 7. And you got to go to the right 1, 2, 3, 4, 5, 6, 7, 8. To the right is positive 8. So up 7 is positive 7. To the right is positive 8. Your m value is 7/8. Now you do it just like number 10. Y equals mx plus b. Where m is, we're going to plug in 7/8. Where b is, we're going to plug in 1/2. It's positive 1/2, so we'll put plus 1/2. Plus down here, 1/2. The rest of it will stay y equals mx plus b. 7/8x plus 1/2. Number 12 says use the slope and y-intercept to graph the equation. Y equals mx plus b. B is negative 4. If you think it's positive 4, you're going to have a lot of problems with this. B tells you where to begin on your y-axis. Begin at negative 4. M tells you negative 2/3. The top number tells you either go up or down. It's negative, go down 2. So from the point we already got, we go down once, twice. The bottom number is positive. It tells you to go to the right 3 times. To the right, 1, 2, 3 times. That's where your second point goes. You have 2 points. You only need 2 points to draw a line. You draw your line through those a little bit straighter than I did right there. And we'll pick up number 13 on the second part.